Welcome to The Cynical Developer, the podcast that helps you to improve your development knowledge and career through explaining the latest and greatest in development technology and providing you with what you need to succeed as a developer. In this episode, we talked to Zach Kessin about Erlang. Zach is a developer with over 20 years of experience for building applications for the web. He started back in the CGI days with Perl, and in the years since has worked with dozens of technologies to bring functionality to the web. In recent years, Zachary's been spending a lot of time asking the question, why is building applications so hard and can we make it better? He wants to understand how to get software development to scale in terms of the services that we deploy and the teams that we build. So welcome to The Cynical Developer, Zach.
Thank you. Been known to be a little cynical myself.
It's the best way to be. The best way to be. Don't just take what everyone out there is telling you about the latest technologies. Get out there, listen to somebody like me, and then go and find out for yourself. It's the best way.
Yeah. I also do sarcasm.
I'm very, very good at that. I try to keep it to a minimum for the show on my part, but it is on my CV and my resume as do top skill.
As the saying goes, sarcasm, just one more service we offer.
Yeah, definitely. And as well as doing all that stuff, you also do courses as well.
Yeah, I'm starting and running a company doing training around Erlang and Elixir on the back end, and then on JavaScript testing and Elm on the front end.
Awesome.
Some of my favorite stuff to talk about. And I'm running some open access courses in London in May. There'll be a course on testing JavaScript with Quick Check and related things like that, and Mocha, which will be a really interesting 3-day course. And then the following week there'll be a course on Elixir. So that's the 9th, Tuesday, Wednesday, Thursday, 3-day course on JavaScript, and then the 15th, which is through the 18th for the Elixir course. And if in both cases, if you use the discount code Cynical, you'll get a discount.
Awesome.
And if by chance that between when we record this and when it goes live, they have sold out, which hopefully will happen, I will run them again, so you'll still be able to use the discount.
That's fantastic.
Can bring them to your company if you would like. Just drop me an email.
Sure. So we'll get all the details, so that will get your discount code in the show notes, and I'll link to the courses as well. Now, with the time shifting abilities of podcasting, that those courses start in May 2017. In case you're listening to this a little later on, so that's the 9th of May to the 11th of May 2017 for the JavaScript testing course with Mocha and JS Verify, and then May the 15th, I think it was for the Elixir one.
Yeah, 15th through the 18th, and those are both going to be on in the city of London, and on Fenchurch Street. So, and if you have questions, feel free to drop me an email or whatever. Sure.
We'll have all your contact details in the show notes. So that's really good. And what we're here to talk about today is Erlang. Now, I'm full of useless information, and one of those gems is that the term Erlang is a unit of measurement used in telecoms. So I guess that Erlang is something to do with telecoms. So could you tell us about what it is?
Erlang was actually a person. I don't remember his first name. It was something Danish.
Right.
And he lived in the early part of the 20th century, and he was a mathematician, and he worked out a lot of the mathematics around telephone switches. And so if you see something like Erlang calculator, or Erlang B, or Erlang C, that is effectively nothing to do with Erlang, the programming language. It's really useful if you want to know how many phone lines you should put into your call center, but not about building applications with Erlang, the programming language. Erlang, the programming language, depending on who you ask, was either named for that Erlang or Ericsson language, or possibly both. It was invented in the late 80s, early 90s at the Computer Science Laboratory at Ericsson in Stockholm. And it was by 3 guys, Joe Armstrong, Mike Williams. Mike's in Wales these days, in your neck of the woods.
Yeah.
And Robert Verding. And they were trying to ask a very simple question. How do you best program a telephone switch? And Ericsson makes these big industrial telephone switches that your cell phone company or basically a landline company would use to, route your phone calls. And if you think about a telephone switch, it has some specific requirements. It has to be fault tolerant. If it has an equipment failure, it's got to keep going. You got to be able to upgrade software on the fly. You can't take half of Tel Aviv's phone service offline for a couple hours while you upgrade the software. That's not going to fly. And other things. And it's got to be easy to. It's got to also be able to handle scale. If you can't handle 20 or 50,000 phone calls or whatever it is, it's not a viable product. So they looked at pretty much every language that existed in the late 80s, found that nothing really met their needs, and basically started playing with their own thing. It evolved out of Prolog, which is why Erlang has kind of a funny looking syntax to a lot of people who aren't used to it.
Yeah.
And but it's been engineered for 20 years by a bunch of people who have serious telecom engineering background. So they are really concerned with things like it will be backwards compatible. None of this, I blinked and suddenly the build system is all different. I got to redo half my build stack. No, it's just going to keep going. Also stuff like it will scale. It'll work very well. They're very conservative with their engineering, which is occasionally frustrating, but it also means that once they put a feature into the language, they tend to have gotten the engineering right. Anyway, so Erlang is a programming language and programming model that is focused around concurrency. And basically, you also hear something called OTP, which stands for Open Telecom Platform. And OTP is kind of the standard library for Erlang.
Right. So it's backwards compatible. So that must be interesting then, because how do they do that? They're going to add a new feature in, and all those previous versions are going to need to know what to do with it.
No, because it backwards compatibility only works one way. So if you take, for example, in Erlang version 17, they introduced maps, which are, key value thingies, which had not been there previously. So if you take code that was written in Erlang 16 and run it on Erlang 19, which is the current version, it'll still run.
Right.
Now, if you try to pass a map that doesn't know what it is from an old module, it won't work. But assuming you don't do that, it'll still go.
Sure. I was thinking of it in the fact that this had to be fault tolerant and not go down and stuff.
Right.
So I was just wondering how that worked from that point of view, and maybe that's where that backwards compatibility sort of helped it out. Yeah.
So in Erlang, if you've ever done concurrency in another, have you tried to do like threads in Java or something?
Yeah, I do. I'm a C# developer by day, so I've done a bit of thread work in that.
Yeah, and it's probably not something you look forward to. I'm gonna guess, right?
Yeah, it's not the nicest thing to be doing.
So, what makes Erlang magic is its concurrency model is very different than what you're used to. It's basically what's called the actor model.
Yeah.
Although that was when they developed Erlang, they'd not actually heard of the actor model. But basically, so first of all, you got to understand Erlang processes are not operating system processes. Erlang processes are a product of the Erlang runtime. And an Erlang process takes like 500, 600 bytes. And switching between them is very, very cheap. So you can flip between them, and it's not like switching Unix processes, which is a very expensive operation. The other thing is that in Erlang, there are only four things you can do with a process. You can spawn a process, which basically just says, okay, create a new process, and it can be on the node you're on or a different node. It doesn't really, it changes the function just a tiny bit, but semantically it's the same. You can send a message to a process. You can receive a message in your process, and you can link. And that's the one that's like the most critical, because what it is basically you can have two processes that say, when process A dies, kill process B, or send a message to process B. So you can basically take all of your error handling. Instead of writing lots of tries and catches, you don't do any of that. You just write a lot of assertions,
right,
pattern matches, and you program the happy path. And then when something goes wrong, your process dies, and some other process somewhere else restarts it. So if you have like a connection to the database, and I don't know, the network goes down and your database goes down or something, your database connection process dies, and it has something called a supervisor, which sits there and just watches it and says, oh, when that thing dies, I should restart it, and it just restarts.
Yep.
And by putting these together, you can make very, very simple, very reliable systems.
Right.
Because your error checking code just gets really simple.
Yeah. Just to break it down a little bit more, it's like a Windows service going off, and it just comes back up, and it just comes back up, and it just comes back up until it finally gets there, or somebody notices that it's not happening.
Yeah, I mean, it does actually have an option that you can put in where it says, if it dies more than this number of times in that unit time,
yep,
then the supervisor fails, and you can have a whole tree of these things. So, and eventually it alerts somebody, because there are times when it's going to try to do something and it'll just fail.
Yeah.
And then the other thing is, when I talk about Erlang, the Erlang ecosystem. So firstly, you have a virtual machine.
Yep.
Which is called the Beam, which stands for Bjorn or Bogdan or some Swedish names, Erlang abstract machine. And then you have Erlang, the language, which is what we're talking about. But you also have several other languages that compile down to Beam files. Elixir is the most common one you may have heard of.
Yeah.
Pretty much everything I'm saying about Erlang is also true of Elixir, except for the syntax is different.
Sure.
Elixir looks much more like Ruby. Erlang looks more like Prolog. But fundamentally, semantically, they do the same thing. There's also LFE, which stands for Lisp-flavored Erlang, which is a Lisp that compiles to Erlang. That was written by Robert Verding, who's one of the original creators of Erlang. He has also created a Lua that compiled Erlang, but those are more toy projects, and I wouldn't necessarily recommend using them in production. There's also like a template library out there called that takes the Django templates that you might see in Python and compiles them down to Erlang modules. And I think there are a few other people who've written other languages that compile down to Erlang runtimes.
Yeah.
The Erlang runtime, but I wouldn't necessarily say. I wouldn't necessarily comment on how production ready they are. Erlang and Elixir definitely, and to a lesser extent LFE definitely, I would have no qualms about using in production. Some of the other ones, I would be a little more. I'm not saying they're not production ready. I'm just saying I'm just not ready to make.
Yeah. You don't want to put your name against it to say go out and use it, and then when it all blows up, you go and you get all these angry people knocking on your door saying Zach told me that this was ready, and it's not, and it's his fault.
Yes, no. I mean, some of these are exactly. So the nice thing also is that when they were building this back in the early 90s, that multi-core wasn't a thing yet. I remember those days, and people kept trying to build parallel computers, and every time they did, somebody would make a sequential computer that just was faster than the parallel one, and kind of was. But then we had the great switch to multi-core, and it turns out the Erlang model, which was meant to create fault tolerance, also works really well for multi-core. So in Erlang, you typically make a lot of processes. If you have a web server in Erlang, you basically have one process per connection.
Oh, right. Okay.
So if you have, if you have 100,000 connections coming in, you have 100,000 processes running its own web server. And if one of those dies, well, that one connection is lost, but it's not. But then the Erlang runtime does a very nice job of mapping those onto the actual physical cores of the computer. And you can, go out and get yourself a top-of-the-line Xeon that has 24 core, 4 CPUs with 24 cores each or whatever. And it'll work. It'll scale. It's really nice. It does require some engineering. Dell's Law still is going to bite you in the butt if you're not careful, but you can do this stuff.
Now, you mentioned this before, but you often see Erlang referenced as either Erlang or Erlang OTP.
Right.
And you said that that's a library for Erlang. Can you explain exactly what that is?
Sure. So OTP, again, stands for the Open Telecom Platform. Open was apparently a big thing at Ericsson at the time. This is in the mid-'90s. Nobody was quite sure what they meant by it, but it was the buzzword of the year.
Right.
So OTP is a set of libraries. It includes a whole mess of things. And I'll sort of give you some of the highlights. I'm not going to tell you everything. The first thing it includes is a couple of standard interfaces or behaviors, they're called in Erlang. But if you think an interface from Java or C#, you're in the right ballpark. There are a couple. So the first one is a gen server, which is a generic server. Basically, you implement 5 or 6 function APIs, and then you have a server. It runs in a process. It takes messages in and handles that, calls your callbacks to handle them. There's also a version that does a finite state machine and an event handler. And these are nice because they've just been incredibly well debugged. These things have seen, countless hours of development, and every possible concurrency corner case has been thought of pretty much. Then you have a supervisor, which is, like I said, the thing I was mentioning earlier, which is the thing that controls other processes. The supervisor's job is to basically sit there and watch other processes, and when they die, decide what to do with them. You can restart one process, restart several, do nothing. And then you have applications, which basically just bundle that also. An application starts the supervisor, which starts the processes that does stuff.
Right.
And applications have environment variables just like a Unix application would do. Sure. And you can turn them on and off, and there's all sorts of structures in there for upgrading things. So you can do rolling upgrades. So in Erlang, for each module, you can have 2 versions in memory at once, an old version and a new version. And under certain conditions, and you'll look up in the book, it will basically, you can switch processes individually from the old version to the new version. So that if you have, let's say you have your web server with 100,000 streaming connections and you want to drop in some new code, you can actually upgrade all those connections without dropping them offline, which is pretty cool.
Yeah. Yeah.
It does require some serious engineering because as you start changing data structures, it can get a little hairy, but you can do it. Yeah. It's not necessarily always the best idea, but you can do it.
Right.
Erlang OTP also includes some other stuff. There's a database called, there are a couple different levels of it, but the major database is called Mnesia. It was originally called Amnesia, as in to forget, but they dropped the A off when some project manager objected to that. There's also, that's basically it has semantics similar to SQL. You can do joins and stuff. It's an SQL-ish thing, although it doesn't use SQL syntax. But the real nice thing is it just uses regular Erlang. Its data types are regular Erlang types. So you can just store, you don't have to worry about, marshalling things back and forth or SQL injection. You can just save your Erlang data structures in and it just works.
Yeah, so there's no mapping that we have to do when we're working with likes of SQL and stuff. You get your data set back and having to map that to your objects. It's all in one, and it's all the same technology, so you're not having to learn another database technology. That's pretty cool.
And it also is distributed, so you can, if you have a distributed system over several nodes, it'll work that way too.
Right. It handles the concurrency between the databases as well.
Yeah, it's a C piece. It's on the CAP theorem. It's not partition tolerant, so it's a CA system. See, I may have that wrong. But yeah, I mean, unless you want to go to something like Ryak or something, which is also written in Erlang, it's a pretty good starter place to go.
Yeah. So does that come with every version of Erlang, or do you have to obtain Erlang and OTP?
It's all if you install Erlang, OTP comes with.
Right. So in the .NET world, it's just like one of the base libraries.
Right. It's just OTP is the base set of libraries.
Okay. So it's a oh, sorry, carry on.
Yeah, go ahead. No, you were saying it's a functional.
Yeah, it's a functional programming languages.
Right.
Let me try that. Try that again, because that wasn't good. So so it's a functioning programming language as well, and concurrency. Can you for the listeners out there that don't know what functioning programming means, can you give us a bit of an overview for that?
So first of all, it's if you've not done functional programming before, functional programming has a lot of different forms. In this case, the major aspects of it there are a couple of major sort of things that are going to look different to you if you're coming from, say, a C# or a Java background into Erlang. The first thing is everything is immutable. You can't, if you would write the statement in C++, x equals x plus 1, or in Java or C, that would make sense. In Erlang, that would give you a pattern match error, because you can't change the value of a variable once you've set it. So what you do is, instead of using a loop, you usually use recursion. So you basically recurse. You have a recursive. This would be much easier to explain with a whiteboard. You basically, if you want to handle a list, I mean, you have list comprehensions as well, but basically you handle the first element on the list, and then the left, and you just sort of take the list apart one by one and handle it. Or you can use a map function and things like that. You use a lot of functions, anonymous functions, to handle things. From Java, it's a mindset shift. It's not necessarily hard, it's just different.
Yeah.
But it has some major advantages. First of all, since everything is immutable, a lot of the concurrency errors go away. You don't have to worry about somebody. There are no locks and mutexes in Erlang.
Okay.
Basically, you send a message to something, and the data structure that gets sent is immutable. So you don't have to worry about somebody else changing it, because it doesn't change. If you send a message from one process to another, if it's a small message, if it's like less, I think it's 64 bytes, it copies it over. But if you send like a 500 megabyte binary from process A to process B, it just sends a pointer, and it handles it in a slightly different way. So you can, if you're live streaming data out to 500, to 1,000 different ports from one, it's a multiplex. It doesn't make 500 copies of that blob of data. It just sends the pointer.
Yeah, sure.
But yeah, you have immutability. Functions are much more you spend a lot more time just working with functions in Erlang than you would in Java. There's also not really any global state. You don't have globals in the same sense you would in C# or Java, although you do have environment variables, which kind of can fill that role. But those are really mostly for configurations. You do things like, database passwords and API keys go in environment variables.
Right.
Things like, what port does your web server run on? That would something you'd put in an environment variable.
Yeah.
Maybe you have it on port 8080 for development, and then port 80 for production or something, or things like that. And again, the processes are much different. They're much smaller and lighter than OS processes. You could run 100,000 Erlang processes on a Raspberry Pi. I know somebody who's done it.
Right. Okay.
You would not want to run 100,000 Unix processes on a Raspberry Pi it would probably melt.
Yeah, yeah.
Or run out of memory or something. But, Erlang processes, that's totally possible.
Sure.
So, yeah, it's a very different mode of doing things, but it's pretty cool.
Yeah, it sounds really good. I guess it's in the same sort of ballpark as Scala and Google's Go. How does Erlang compare to those? Are they comparable, or are they for really different niches?
I'm not going to comment on Google Go because honestly, I've not actually looked at it more from beyond the hello world phase.
Sure.
Scala certainly borrowed, especially the Akka framework, borrowed a lot from Erlang. It's a much more recent development. Erlang really started, in the early 90s, where Scala, I don't know, it's like mid 2000s. So certainly the Scala people were borrowing ideas from Erlang and from Haskell and other languages, which is, a good thing. If you're going to invent a language, you should take advantage of what people have done before you. But Scala took the position that they wanted to have really good interop with Java, which has its pluses and minuses. Erlang was really hyper-focused on that one problem of building telephone switches. It just works out that a web server kind of looks like a telephone switch in some fundamental ways that might be non-obvious until you start looking at it in detail.
Yeah.
But you need to have be able to handle lots of concurrent connections. You need to be able to handle heavy load. You need to be able to isolate things. So if you have a web server running 100,000 connections and one of them drops because of some software bug, well, that's not great. But if you lose one connection, so what? What you don't want is for it to cascade and take down your whole server.
Yeah.
The other thing that Erlang has is that each process has its own memory heap. So garbage collection is done on a per process basis. So, in Java, sometimes you got these, general stop the world garbage collection events going on. Erlang doesn't do that. Each process garbage collects on its own.
Okay.
So you may have, one process may pause for a little bit while it garbage collects, but it doesn't block the whole system. It's really very focused on making sure the system as a whole is stable. Even if you lose a process here or there, which apparently, unless you have some weird bugs. Erlang, unlike, say, Scala, is also mostly not a typed language. Erlang started out descended from Prolog, which is a dynamically typed language. Some folks at Uppsala University in Sweden went and added some typing on top of it with a program called Dialyzer, which does some wonderful static checking on it for you. And I highly recommend using it. But it does not have sort of the same guarantees you might get in, say, Scala or Haskell or Elm that, you just don't get those level of guarantees. On the other hand, since you need to be able to upgrade software, you need to be able to handle the case of, all right, what happens if a message comes in with a type I don't recognize because I'm version 1 of the software and it's coming in from version 2.
Yeah.
Probably it fails, but there are all sorts of corner cases there are some cases for which Erlang is well optimized that static typing would make, I think, rather difficult. Again, largely around the whole concept of dynamic upgrades.
Yeah. Okay. Yeah, and Scala, I think, if you're coming from a C# or a Java background, the syntax is a little similar. It's a little bit more familiar than Erlang, which you mentioned is very, very different. Yeah,
Ruby, Elixir has a syntax that is much closer to Ruby than, the semantics are not particularly Ruby-like because they're much more Erlang-like, but it has some of the metaprogramming stuff that Ruby people seem to love.
Yeah.
But it still has the underlying aspects of Erlang. And assuming you don't do anything too like run out of memory, it's very difficult to crash the Erlang virtual machine. Right. You can do, but it takes, absent running out of memory, in one way or another, it's really hard.
That sounds like a challenge for anybody out there that wants to learn Erlang.
Well,
Get out there and see if you can crash
if you
it.
want to debug a running Erlang system, it has also has lots of great tools for debugging Erlang systems.
Yep.
There's a book on it. It's a free ebook by Fred Hebert, who works at Heroku. So there are two. Fred has written 2 free ebooks. The first one's called "Learn You Some Erlang for Great Good." Heavily recommended. You can buy it from the Starch Press if you want a paper copy, or you can go on his webpage. If you can type "Learn You Some Erlang" into Google, and it'll come right up. And the other one and it'll teach you Erlang. There are a few. Make sure you read the appendices, because there are a couple things that he added later, because when he wrote the initial book, they weren't really there, or they were added to the language after he wrote the book.
Sure.
Specifically, maps and Erlang's handling of time got much more sophisticated recently, because it turns out handling time in a useful way is a really complicated problem.
Yeah. So I'm told.
It's like if you need to handle time really accurately and well, go read the document. It's like 50 fallacies. There's a document there like fallacies programmers believe about time. And yeah, it's got some weirdnesses in it. What happens if you close your laptop and then open it up again, or
Yeah.
The fact that you have a distributed system, clocks across several systems are going to not agree on time. If you have three servers, they'll agree to time within, some fraction of a second, but within the time of, if you want to know which of these events happened first on a distributed system, it turns out it's a direct, special relativity is still a thing, and you can't actually answer that question in a useful way. That's why you do things like vector clocks and stuff in RIAC.
Yeah.
Or, git commit histories, which basically are vector clocks. Because the concept of that A definitively happened before B, it's hard to make that guarantee. That doesn't work. Like I said, special relativity, it's still a thing.
Yeah.
And, clocks drift for all sorts of reasons. And, including things like, somebody put your laptop into sleep mode. You cross the international date line, which probably isn't a concern for many systems, but not all of them. So yeah, Erlang's timekeeping has gotten a lot better, but it requires some, as programmers now, we have to actually pay attention to this stuff.
Sure.
The other cool thing about Erlang is, one of the other cool things, many other cool things about Erlang. If you go to the Erlang User Conference, which is in Stockholm in the early summer, recommended, or Erlang and Elixir Factory, which was in San Francisco in March. If you go to a Ruby conference, you probably won't meet many people who are university researchers whose job it is to research, computer science research. In an Erlang conference, you'll meet a bunch of them. There are a bunch of people at universities in the UK, mostly the UK, University of Simon Thompson, University of Kent, Kevin Hammond at St. Andrews, as well as some folks in Sweden who are doing research, computer science research on the frontiers of Erlang,
Right.
on how to currency, how to do validation, how to do different kinds of testing, and getting serious money from the EU to research this stuff, and other sources, I assume. So some of those ideas are sort of slowly, or not so slow, or in some cases even quickly, seeping into the mainstream of the Erlang world as, these concepts are really pushing their way in. And that makes the Erlang ecosystem even more powerful, because, you just have people who are very smart and funded to come up with solutions to hard problems.
Yeah. Yeah. So we mentioned there that Erlang could be used for web development or website stuff, and that it's used for telephone systems and research. Now, from a .NET world, if I need to build something, I can build pretty much anything I need. What sort of application would I be looking to build? that should make me really think, oh, Erlang might be good for this?
Okay, there are a couple things. First of all, if you want to build a chat system that has to handle anything that has to handle huge scale, it has to handle it in a predictable way, or it has to be able to handle loss of a node.
Yeah.
So, some prominent things that are written in Erlang that you may have heard of. WhatsApp, first of all, is largely Erlang. I'm assuming everybody has heard of that. At least if you're not, unless you're in the United States, in which case most people seem to not use WhatsApp in the US. I don't know what's with that.
Right. Okay.
Well, actually, I think there's not even more. Much of the world's telephone systems. There's some things. The RIAC data store from Basho is Erlang. RabbitMQ, and then there's an instant message client, Mongoose. If you actually want to build, if you're new to the Erlang world and want to build something web related, I would actually recommend not using Erlang, but using Elixir and the Phoenix Web Framework. It seems to be where a lot of the energy is being focused these days in terms of how to make it, a really nice experience for developing web stuff. Okay. I personally use straight Erlang with the Web Machine framework, with Web Machine, which is also a lovely piece of code, which is also from Basho. But yeah, the thing you're going to get with an Erlang or Elixir system is it's going to really handle a heavy scale in a very predictable way, in a way that you might not get from some other systems. Now, I've not really done much with .NET. I've not really done anything with .NET personally, so I can't comment on where .NET falls down.
Yeah.
But when you start getting to those scaling problems of, oh my God, the world is just getting huge, and you're passing lots of messages around, that's when you should consider Erlang. There was a great article on the Elm site, but this is true of any language, how to use Elm at work on the Elm language blog. And this is what, they were talking about Elm, but it's true of Erlang. If you have a working system in, say, C#, don't throw it out and replace it with Erlang. That would be a very stupid thing to do. What you should do is find some, smallish piece that, may need the special properties for Erlang and, set that up. You build that in Erlang.
Yeah, build a piece of your system in there.
Yeah.
Yeah, because I know people use RabbitMQ with .NET, so so you might not actually know it, but you may already be using Erlang.
Oh yeah, totally. There's lots of things. CouchDB, at least was for a while written in Erlang. I think it still is. RIAC, which is wonderful for building large scale stuff. Distributed systems. They seem to get the whole distributed systems cap theorem right in a way that some of the packages seem to not. So on and so forth.
Sure.
So yeah, those are sort of the places to look.
Okay. Do I need to be on a certain operating system to write Erlang, or can I be on Linux, Unix, Mac OS, Windows?
Usually it's deployed on. I would not recommend deploying it on a Windows server.
Right.
Most people deploy it on Unix of some form. But certainly have Erlang running on my Mac laptop. I've certainly run it on Windows before. And certainly Linux. One word of warning: if you install Ubuntu, it comes with Erlang, a very old version of Erlang. So old versions of Erlang up through 16 had the version numbers were R, the letter R, a number, and then A or B, where A is alpha and B is release. So you might see R16B03. Starting from version 17, they just sort of go to the more normal 17.0. The current version is 19.3. It just came out a couple days ago from when we're recording this.
Yeah.
So if you're running Ubuntu, go to the Erlang Solutions webpage and download, connect, upgrade to a more recent version of Erlang. The old version will still work. It just isn't. It's going to be a lot of things won't work with it. A lot of the modern tools, because most people aren't supporting that old version anymore.
Yeah.
But yeah, Erlang will work just fine on Windows. It'll work just fine on most Unixes. At least, when I say most Unixes, at least Linux, BSD, things like that. If you're doing something, one of them, if you're running it on, if you're trying to use Erlang on AIX, I have no idea if it'll work. But
Sure.
actually, I know it won't, because there was a discussion on the mailing list of how to make it work the other day.
Great.
But certainly on any of the major OSs that you might try to run it on, it'll work. It'll work on a Raspberry Pi. It'll work on, I believe it works on even on a Knights Landing Xeon Phi, which is that new monster chip that's coming out that has like 250 cores on it.
Nice.
I don't know how well it'll work on that. If it doesn't work well on it now, I'm sure people are working on it.
Yep.
So if you're looking at one of those going, how in the blazes do I code for one of those? It's basically, the chip is, it's like, it's ginormous, but it's basically 72, depending which model, up to 72 4-core Intel Atom or 4-thread Intel Atom core. So you effectively have about 260 threads running on one chip.
Right.
So if the thought of doing that in C# or Java makes you break out in hives, consider Erlang.
Yeah.
I don't know what the status of it Erlang on that is right now, but I'm sure some folks are working on it if it's not fully supported.
Yeah.
So that is, and it's a really nice language to work with. It takes a little getting used to, but the engineering behind it is really good. And once you sort of figure out where everything is, it all kind of works.
Sure. So if our listeners wanted to go out there and maybe have a play with it, is there any websites or blogs or courses that you could suggest for them to go and have a look at?
Sure. Well, if you want to just straight Erlang, if you want to just learn Erlang, Simon St. Lawrence, formerly who was at O'Reilly, he's not there anymore, just came out with version 2 of his book Introducing Erlang. You can get it from O'Reilly. I wrote a book called Building Web Applications with Erlang. It's a little outdated, but still good. It's using the Yaws web framework. And the best book to learn Erlang is, like I said, Fred Haber's book, Learning Some Erlang. When you get into stage 2, your best bet, there are a couple other books too. The best book, sort of is the more advanced book, is Designing for Scalability with Erlang OTP, which is by Francesco Cesarini and Steve Vinovsky. Really good book. There's also Erlang and OTP in Action and a couple others. Joe Armstrong's book from the Pragmatic Programmer, Erlang in Action and Elixir in Action from Manning. There's no shortage of books. Learning Some Erlang is quite good. It's free on Fred's website, so you can just, go read it. You don't have to pay for it, which is nice if you're short on cash or, don't know if you want to do this. That is sort of it. There's also the Erlang runtime system for the pragmatic programmers, which should be out eventually. It was originally going to be out from O'Reilly, and then I don't know. Oh no, it says the title's been canceled. Scratch that. That book was supposed to be out, and then it wasn't, and I don't know what's up with that.
Yeah.
Sure. But basically, there are no shortage of books, and there's also, like I said, the other book is Erlang in Anger. It's again a free ebook. You can pick it up. Just type Erlang in Anger. Because one of the cool things you can do with Erlang is you can sort of, as an operator, you can go into the console from the Erlang console, and you can tell it things like, I want to see all messages, every time this function is called with these parameters in this group of processes. And there's a library called Recon that lets you do that very easily and in ways that are like runtime safe, so it won't blow up your system if it's called 100 million times a second or something. it'll show you the first 20 and then stop.
Yeah.
So that's really nice if you have these weird bugs that, concurrency bugs are hard, are reduced in Erlang, but they don't go away completely. They still exist. And they're occasionally a real pain in the neck to diagnose. So that's a really nice thing. There are lots of other stuff going on in the Erlang space. Also look on the Erlang subreddit and the Elixir subreddit as other good places to look.
Fantastic. Yeah, we'll get all those books and ebooks linked up on the show notes. I will also link through to the Reddit and subreddits for you. And there'll be the discount code for the testing courses. So that's great.
And also an Elixir course, there'll be a discount code for that. So
okay, fantastic.
And yeah, that's that. And this is the thing with Erlang is nice is, like I said, the language moves slowly, which is occasionally frustrating, but it's also nice in that, you're not suffering from whiplashes. Like sometimes with some languages, it's like they change their mind every 6 months and can drive you a little crazy. It's like, wait, I thought we were doing it this way. No, we're doing it that way. Oh, okay. It's much, much more thought out than that.
Sure.
So yeah, that's sort of the thing. And you can easily find me. I'm on Twitter at Zach Kessin, and my blog is get-finch.com, which was offline for a while, but should be back online by the time this goes online. And I'm also on LinkedIn under my name, which is, nicely unique. So I'm easy to find. Yeah.
Fantastic. Well, thanks for coming on and giving us an overview of Erlang. It's something I've not looked into at all. So I hope it's going to be of some good use to our listeners.
Yeah, I didn't, obviously can't tell you everything with the language in 40 minutes, but I hope I gave you enough to make you curious. And yeah, and go enjoy, play, break things. And I should have some blog posts up between now and then on other useful Erlang stuff, I'm sure.
Fantastic. So thanks for listening to Cynical Developer. I'm James Stoddart, and you've been listening to Zach Kessin talking about Erlang. If you enjoyed this episode, please leave a review on your favourite podcast platform and help the Cynical Developer to grow by increasing its audience. If you have any questions about this or any other episode, then drop us an email, a tweet, or leave a comment on the website, where you can find all the resource links and show notes for each episode.